So, we have created an AI system, but does it scale up? So, we are now on a previous build, and I think it's exactly the previous one, and I have 10 enemies in my scene. Okay, let's unpause. We will wait until somebody spots our player, and we can start seeing the spikes. Now, we're only going to focus on optimizing our AI, okay, and everything that has to do with our scripts, because as you can see in the profiler, there is other stuff also that have to do with optimization. Alright, so camera render is pretty much how much meshes they have to render, and of course the animator is also a powerhouse. It takes a lot of performance, the nav mesh, and here's what we're going to focus is the behavior update. And of course mesh skinning update is for the mesh skinning. Now keep in mind that the models I'm using, so we're going to be seeing some spikes only just from the models. The character models, I think it's about 16,000 faces, so that's a lot, that's very a lot, and we do not have any LODs, and the rifle alone I think is about 30k. So okay, we're going to disable them a bit later so that we can see more accurately what we need to do. We're only going to focus, as I said, only on optimizing the behavior update. So we're going to try and minimize this one, the behavior update. I hope you can read it actually. Okay, so from what you can see, everybody seems to be they actually killed me directly. So let me make my character have or maybe wait a second. So let's see it once again. I had some behavior that they were actually doing damage to the player. Okay, we see some spikes, not all of them of course. Our behavior update is not that it's good actually. So without doing any changes from what we had, we can have 10 enemies, and I actually want all of them to start shooting. From what we can see, they start shooting, and here we have one spike. Now we can see that the biggest thing is also of course the physics that makes the spike. So let's continue. And from what I can see, it stays around 60 FPS and now even more. But can we scale it a bit more? So let's make another thing. Keep in mind also that I'm recording. Okay, so some stuff might be, we might get some spikes because of the CPU usage. And now we see some bigger spikes. Of course the green part is the rendering, so of course it's going to affect, because we have each one of these is 16k faces, multiply that by 20, you'll go way over budget. If we open it over here too. Okay, but we see this FPS, we're not going to focus with this. Let's just focus only with this. So I'm going to close this since this one is more appropriate. Okay, but here is one of the spikes, and I hope you can see it, but we now have the problem that the behavior update is actually taking more time. Takes more time to calculate the behavior update than it takes the camera rendering and the physics processing. Okay, of course this is a problem, and this is due to garbage allocated, okay, to the garbage collector. So it says to you that it takes 45% and nearly 46% of 14 milliseconds. Okay, that's too much. Let's see. And you will see that it goes and goes and continues, and it's pretty much start getting a lot of memory. Let's see if we can scale it even more. Okay, because it was, even if it was that much, it was actually okay, playable. Let's make it to 40. Now, of course the level is a real level, will actually have a lot more items, so there is a lot more usage in the power, in the mesh, the renderer and all that. And of course in a real application you wouldn't see 50, you wouldn't have that many enemies. If you think about it, in the most cases you will see in games that have AI that they actually shoot you, okay, they aren't really there aren't really that many enemies at screen at once. And of course if all of them were shooting at the player, then the player will probably be dead in 2 seconds or even less than 2 seconds. And of course we can see over here that the blue spike is straight from the scripts, and now it's 64% of 50 milliseconds. Of course that is a big amount of time, and you can see that if you see the FPS over here, we are at 25% FPS. So what we can do to actually optimize our scripts. Now I'm going to go into the new project, but before I go, okay, the way we have it over here for a single enemy, so that means for all enemies, we have character stats. It has its own start, it has its own update. Our enemy AI has its own start and its own update, and everything else runs from the enemy AI. And we also have the side script and the weapon manager, of course, but the weapon manager pretty much only runs on update, and the side script that has its own update too, that starts does a recast towards a target, towards an enemy, or just checks the direction. From what I see, doesn't do a recast yet, and sees if he can see the target or not. Now what we can do to change that is to make a manager and actually decide and set our own budget of how many enemies we want to update. So let's go back to the latest version. Now we're back into the latest version with the changes we're going to do on, oops, let me close this one over here, and I want this one, or better yet, this one, and this one, and I want all of it. Yeah, anyway, let's just have it like this. Okay, we have 40 and even more than 40 enemies. Okay, there's actually one extra, I think. There might be some few more. Okay, let's see what will happen after the changes we did over here. that we're going to see today. Now, there's some pitfalls to this, and I'm going to talk about it, but we're going to see it, what changes it does. Now, the first spike doesn't matter, okay, it's the initialization, but we're going to see when we actually see a spike, okay, where that spike comes from. Now, of course, we are at 30 FPS right now, because I'm also recording, do not forget that, and of course there are 40 enemies and buildings inside the scene. And let's see the next spike. Okay, physics processing, animators, all that is of course pretty much we know about them. And our behavior update has dropped to 0.3 from 0.14 milliseconds. Okay, it's pretty much nothing. So let's see where they actually start shooting, and I'm going to talk about a bit for the pitfalls. And of course these are a lot of enemies, and I should probably change the resolution of the texture so that we can get actually get some good FPS. Now the problem with this is since not all of them update at once, is of course that behaviors that need to run on update, let me mute that, okay, they do not run on every frame basically. So we split our budget, and right now I have it like they are 5 per frame, or it does 5 updates per frame. Of course you can set this up to whatever you want, okay, but you can see that for every spike hog we have, the behavior update is pretty much eliminated. It does 0.2 on 0.19 milliseconds, and even if we find a blue spike like this one, okay, it's pretty much the same. It doesn't like this one is one more, it's a bit over, so that bit over is 0.4 on 0.21 milliseconds. Okay, so this is a good thing. So because you have 40 enemies over here, and your scripts are not the ones that are messing up your AI. Now I'm going to actually make a new camera, and I'm going to get rid of the old one, and I'm going to get rid of the image effects too. Okay, since we are we're pretty much benchmarking over here, so we do not care about the effects. And I'm going to go into my project, and for all the textures I have inside my project, I'm going to select my 2D textures, and I'm going to pause the video and change this to 32 resolution. Okay, so I'll pause the video. So now that we have lower resolution, like significant resolution, or I could just delete them so I know that there's no memory used on the textures. The next thing I'm going to do is, basically I'm going to delete all the enemies, and I'm going to go into my major one, and start basically close the mesh. I'm still keeping the muzzle and all the other stuff. I'm only closing the mesh, okay, and I do not have anything else. If I had an animator too, I should have disabled the animator. Now keep in mind that still this enemy has 4 to 5 different materials, okay, this character. So that alone is a lot when you are going for performance basically, or low-end platforms. You need to make sure that you have optimized every part. Okay, as I said, we're only going to focus about optimizing our scripts because this needs retopology, change the character, and it's not basically a coder's job to do that. So keep that in mind for some FPS drops we're going to see. Now I'm going to duplicate. Okay, we have 5, 10, 20, 30, 40, let's try 50. Let's hit play. Now keep in mind, as I said, and as I'm going to probably say a lot of the times, we are only looking for optimizing the behavior update. Okay, so we're starting with some high FPS from the start, and we see that all the drops that we have are from stuff that we already know they're going to be a problem. Okay, physics processing. Keep in mind that all of these characters have ragdolls on them. Okay, so in a game like this, you wouldn't want the ragdolls to be always on them, or you basically wouldn't even want ragdolls, like Total War doesn't even have the ragdolls. Okay, the NavMesh manager, because everyone has a NavMesh, but that isn't really the problem, since the NavMesh alone has its threading, but it has to update the position each time. So the way they are moving, since they are using the NavMesh manager, it's controlled by the NavMesh agent, so it's another thread. It's not the main thread that Unity has, or I don't know how they set it up, but we do not have to worry about updating the position if we are using the NavMesh agent. Okay, animator update. Of course, the animator takes a lot of memory and a lot of performance. It's taken from the animator, and we have all that many. And all these characters have around 64 bones. That means 64 bones multiplied by 50 plus 1, then a lot of memory and all of that. But we can see that still our behavior update doesn't take anything. So with that, because we can set our own budget, we can actually predict its behavior and the performance it's going to need on our scripts, and that of course is pretty powerful. Okay, you can imagine how much stuff you can do with this. Now, for a game that has so many enemies that can, of course, shoot you directly, you're not going to see this thing. Okay, but you might, in a case like you want to have all these enemies in a single game. Okay, then you will start the grouping. So instead of updating just one unit, you will update a whole group and set behaviors for that group and all that. But that is out of scope of this particular video. We will see what we're going to do in the future for that. So what we did to do the changes, now you can see that they look like stuttering, but you can actually see that think of it like only 5 of them are updating. Let me put the camera a bit closer. Okay, you can actually see that only 5 of them update every frame. All the others wait for their own frame to update and all that. But we have a way to actually override this. I just didn't add it for all of them. Okay, because we're now testing the update. And okay, we will see and we will talk about what can be done differently and what can be done to eliminate this thing. Now, if we only have 10 enemies, you will see that they are actually updating like normally. Okay, 5 of them will update on frame 1, the others will update on frame 2. Now we are counting, of course, since they are updating frame by frame, that means they'll be identifying the target slower. Okay, you will see that some of them fire on one frame and the others fire on the other. And if it was only one, then it will be like updating on every frame and all that. So what you can do later is make the characters that have to update on every frame, have them differently on their own list of what to update, and all the others have them into the backend, so they don't even need to update on every frame. They can even update every 5 seconds. So let's see the changes we need to do, and the changes will be on the enemy AI and character stats. Basically, the updates we had previously, we had our enemy AI, we had an update over here. We're going to do that, we're going to change that to public void tick, but we're going to keep the void start, and on the character stats we're actually going to make that not start, character starts definition. Okay, we're going to make the start a public function, and we're going to make its update a public function. Now, the character movement and the AK handler, these things update from the character stats because we share them between our player and the enemies. Okay, so that's the only thing that these two share. But the enemy AI is going to focus on updating and initializing the character stats once again, and the previously enemy manager we were finding by tag. I just made it a singleton because it's safer. Okay, we'll see in depth the enemy manager in a bit. Okay, of course we need to add the enemy manager on the enemy manager, similarly as before in the list, but the all enemies list we had on the enemy manager, I've changed everything from character stats to take the enemy AI script instead. Let's go back to the enemy AI, and then on tick, so whenever you call this character's update, you're going to call the updates for the character stats and the side sphere. The side sphere is, you need to set this up if you haven't already, public enemy side sphere. Okay, the initialization and the tick, which is the update, but we're updating it when we want. Okay, now keep in mind to set up the references as they should be. Okay, initialize them, side sphere also, initialize it, and all that. So without the enemy manager, the characters wouldn't do anything. and we also need to set up the weapon manager initialization. Okay, instead of start, just make it initialization, and when we are initializing the IK handler, the character stats, we also save the weapon manager, since this is also shared with the player, and update it before we initialize it before we initialize the IK handler. Okay, this is, if you switch it the other way, then you're going to get an error on IK handler probably. And on tick, since the weapon manager doesn't have a tick, we do not have to include it into the update. Now, what we do on the enemy manager is, let's see the singleton first thing. Okay, the singleton, if the instance is null, then go create a new game object, add the enemy manager, and add the component and initialize it. Just in case if there isn't an enemy manager, but you should always include the enemy manager yourself, since we also have some behaviors that we can actually affect and all that. Okay, now on start, to start, we have our lists: enemies available chase and enemies on patrol. We're basically not using them. Don't have to be ignore them for now, so I'm just putting them over here, but I'm not deleting them, since we are calling the behaviors from the enemy AI too. Okay, we've seen some uses for this, but we're only going to focus about the next stuff. All our enemies that they are inside our level, and another list of enemy AI, which is to override the update order. And this is if an enemy goes into a behavior that has to update every frame. That frame could be a behavior that has to do a lerp. As we will see an example for that is when they are actually rotating to face a target. Okay, there you cannot if you use a coroutine, it's going to feel pretty choppy, but you have to update it, otherwise it's going to make it looking like stutter. Okay, because it's not going to be updating on every frame, so you have to override it somewhere. So this list will be for behaviors like that. Now, what we do with these lists, we also need to focus with this stuff. We need a list of enemies which will be updated in this frame. So we will call that to tick the enemy index and our enemy budget. This is how many enemies are going to be updated per frame. If I change this to 10, then we're going to be updating 10. Okay, this is entirely up to you, up to your platform and all that, to set up the way you want it. And this is for initialization, because if you are doing a lot of stuff and you have the new keyword inside update, okay, this takes a lot of the garbage collector. Basically, it makes a lot of usage for the garbage collector. So it's best to initialize variables, as we will see in a bit, and use them from there, but I only have it as an example over here. Okay, so on start we call a new coroutine, which we'll see, which is called my update, and the new update is this one. So it's another coroutine, it's not the basic update, and there's a reason for this. So we have a coroutine, my update. To tick, we clear the previously updated units, and we see for every one that allows on our enemy budget, that our enemy budget allows, we're going to check if the enemy index is lower than the all enemies we have. That means we haven't gone through and updated all our enemies, we're going to add an enemy to our to-tick list based on our enemy index. Then we're going to add to our enemy index. If we haven't, then we're going to set the enemy index to 0, and this will skip a frame, but you can also add it to start to basically add to tick this one once again. But okay, it doesn't matter, it's just a single frame, it doesn't really much matter, nobody will even notice. Okay, so because AI behaviors and all that, they are not directly communicated to the player. Okay, the player doesn't know if an enemy is sitting idle because its behavior update hasn't yet come, or of course sometimes it does so, but that's just some bad created AI probably. Okay, so after we have created our list, or not created our list, after we have separated the ones we're going to update in this frame from the rest of them, okay, then we'll start a new coroutine, and we're going to wait till that coroutine ends, which we'll call ticking. So for every list we have to be updated, for every unit we want to update in this frame, we're just going to go into that one and make it to tick. Now you can use a for each loop, but for loops require a bit less memory, so okay, it's pretty much the same at this point. To tick, this is if you want to separate them into other lists, if you want to do other stuff and all that. Okay, this is I'm just keeping them like examples basically over here, like the wait for end of frame. Now okay, you update the tick and you check if you have anybody in the override update order. That means even if it's over here, then you should also update it. But you should probably also do a check if this one, and let's see it, if to tick dot contains override update order I, and we want the negative of that. Okay, so in theory it shouldn't be included over here, since we're adding at the end of the tick, you'll be adding inside the list. But just to be safe, just so that you know that it doesn't update in 2 frames, it wouldn't be wrong. Most of them wouldn't even notice. Most of the people that we're going to see, your players wouldn't even notice. Okay, but let's just be safe. Okay, so if it isn't have just updated, it's not going to update it once again. Even though in most cases, like lerps and all that, since the delta time will actually be the same, it wouldn't even matter. Then you can do either a yield return null, or you can actually call it to end the frame. But if you use it indeed the yield return end frame, you will sometimes see some spikes because you've made it to wait for the end of frame, but it drops the frames because you actually set it to wait till end the frame, so go figure. Okay, so either use see what suits best in your game and what suits best into your platform basically. Okay, now keep in mind that these are coroutines, so I do not know what they are going to do about how they are going to work with mobiles, but judging from the GC allocated that we have, I can see that there isn't really that much from the behavior update. So okay, testing it will if you test, you need to test it basically on your target platforms and all that. Now, after we finished with our ticking coroutine, what we do, we call again our update. So next frame we'll get the other 5 and the other 5, or how many we have set on the enemy budget, and update those. Now, as I said, this has one problem. If we have 60 enemies, then the problem is that for a unit to keep updating, to update once again, it will take him around 60 frames, or not 60 frames. If you only update one, it will take him 60 frames. If you update 5, then it will take him 60 subdivided to 5. Okay, so what that means is if somebody shoots on one frame, it's going to shoot again on if we are only update one update, it's going to take him 1 second if your game is running at 60 FPS. Now of course you can see how that can be a problem, so that's why we have introduced the override update order. Let's see an example for that. We're going on to our enemy AI and we're going to see where we are calling the function to look at target with the IK, of course. We're going to check to see, and we were doing all this basically. Okay, we were finding the angle and all that. We were rotating, but we're going to add, when we actually want to rotate, we're going to go and say to the enemy manager and add this enemy AI script into your override update order. And it overrides, and when the angle is back is less than 1, then that means there's no longer a need to override your update order, just wait for your own turn. Okay, and with this, if I change this, if I remove this, you will see, and let me make I think they are 30 or what, how many. Okay, we're going to go and make them see us. The first spike doesn't matter, as always, and we actually have to wait till they shoot because that's when we're calling that the look target IK function. Now of course all this stuff are pretty much optional. If you do not have all that many enemies that can attack at the same time, it's pretty much useless, but it's just good to know. Okay, then I start aiming. The IK helper doesn't update in every frame, that's why you see that stutter. And if I you see that the rotation of the body, it takes them so long to update because they have to wait for their own update to actually update. Okay, they have to wait for their own turn to update. But if we remove this, now keep in mind that you should probably make a manager for every enemy to update in its own turn, and you should do that because you will probably have a lot more you have the IK handler, you have the rotation of the enemy, the rotation of the body, and you have pretty much everything else you might have there. Okay, and all that, if you remove him from the list before that one updates, before everything ends, okay, that means you are closing your target. Okay, so that means you have a behavior that haven't updated this frame, so that can be a problem. So you still have that stuttering. And let's see it once again, and let's actually see where we update the alert behavior as target, what we update over here, so we can make it to be a bit faster. And it was on the tick, target available. No, how was it? Yeah. And all these timers, of course, need to be rethinked from the start, since they are not updating on every frame. And you can see that we have another one rotation over here, so that also needs to be thought of. Okay, so we pretty much need a bit of refactoring in most cases. So yeah, I can't find the alert levels, so let's just continue on. Doesn't matter now. So let's play. Let's clear this thing also. Okay, you see that behavior update doesn't pretty much changes a lot. And let's wait till they start shooting. So you can see that how this can be powerful, but of course you need to have you need to think of a bit more from the beginning. If you know you're going to use that many enemies, then your whole code needs to be changed. Okay, you see that they rotate immediately, almost immediately, or how they used to rotate when they were updating on every frame. And you see that the AK handler just stutters back. So let's see. Let's go into the AK handler. Yeah, wait, look, wait, and now if we did that, we will actually have to do a bit of changes. So let's think. Let me think. Animate look position. Tick. Now we need to go into wait or handle shoulders, most appropriate. Okay, and yeah, and wait. Target helper. How am I calling it? Not left hand helper. Right shoulder. Aim helper. Okay, we have a lerp over here, so that means is an actual problem. So let's write something fast. We're going to say if float distance equals vector3 dot distance the aim helper position to the stage lock position, and if that distance is greater than 0.5, then go to the enemy AI and we do not have the enemy AI, but we have the states, and we do not have the enemy AI. So let's just go and add it. Enemy AI and AI, but we're going to say if enemy AI get component enemy AI, and yeah, we're going to delete that, and we're going to add it in a bit. We're going to add this into if enemy AI, so it will only, since we use this on our player 2, distance it's greater than 0.5. You can of course fix that to whatever you want. Then you will go into your enemy AI, to the enemy manager, which is not public. Well, we will do it public over here, but later on we're going to make something to use something better for this. Okay, like making a manager and all that. And basically wherever you rotate your character, you want to rotate from one function. And key handler, let's say enemy AI, enemy manager that dot override date order add enemy AI, else. Now here is where we're going to face the problem, is that, yeah, well, let's just keep it. If we keep it over here, we're going to have the problem that yeah, you get some, let's see it actually, if we do not remove him over here, but let the enemy AI or the turning of the character decide when you are out of the update order. Let's see, we'll probably get some more. And yeah, for some reason it works just fine. Of course, I don't know what those are doing. And our behavior update, from what I can see, in most cases is still doesn't even care that much. Of course, we only have 30 enemies. But they are updating on every frame, from what I can see, all of them. So they are shooting on every frame too, so that's bad. And they are actually updating multiple times, because this happens basically every frame. So we need to say enemy AI, enemy manager dot override contains enemy AI, and that goes for, if not contains the enemy AI, and only then. There was a spike for some reason, it was the physics. Okay, now they update normally and based on the override update, and you will see that their IK works as it should. Okay, it works smoothly, but if it's under the threshold, it stops. Now, not stops. If they have to rotate, it's going to stop. Otherwise, it's not going to stop. Okay, as I said, you need to set up a manager for when you call the override update and all that, and we're going to see that probably in a later video. Okay, this doesn't have to do so much with AI, it's mostly optimizing, but keep in mind, if you have that many enemies, then you probably won't even have IK handling for each enemy. Okay, if you're gonna save on performance, then the IK is pretty much a luxury at that point. Okay, so if you're going for many units, then that isn't how you're going to use it. And from what we can see is that our behavior update is pretty much doesn't take anything. Okay, 0.4 from 0.18, that's, and it pretty much goes to that. Let's add some more. Let's make it 60, shall we? Let's put them somewhere over there, I don't know. And if it doesn't crash my PC, we're going to see it. Yeah, of course there's going to be major FPS spikes from all the other stuff. Okay. Because we have a lot, and because we're using the left hand IK, okay, this also has a problem. That's why he's dragging back the hands. Let's see the spikes we have over here, and they are even on the bigger spikes we see that says it's from the scripts. You will see that it's not our behavior update. Okay, it's pretty much stays the same, and that is pretty good, to be honest. And as I said, we need to worry about mostly on your poly count budget, the physics of course, and the animator. But after the meshes, okay, these do not have any LOD on them. They have 5 materials per character. That's way too much. So after you have created your characters into a budget, so something that has a lot of players in the same at the same time on screen, then that means you're probably looking at lower than 5k to, at some cases, depending on your numbers, to 1k per character. Okay, even if it's for a PC sometimes. Okay, it's because if you watch some videos where they're lower speccing even GTA 5, for example, you'll see that LOD 5 is like less quads than you had in PlayStation, in the first PlayStation. Okay, so as far as script optimization goes, you will see that I think we did a pretty good job over here. So we covered everything we have to cover. Keep in mind that this is kinda optional. I don't know if everybody will feel will need this. So I'll end the video here. Go like the video, subscribe of course if you haven't already, and if you like to see more stuff, of course, then consider supporting me on Patreon. You now do not have to wait till the end of the month Patreon. Okay, there's been some changes to Patreon, so you get instant access to the Google folder with all the scripts, and also there is the projects on Gumroad where you can also support me with them too. So I'll see you next time.